You can see literally in a window, we have Ubuntu running. Oh, Docfully, this is Jock, right? I do believe so. What's up?
I had a question about I wasn't able to attend the last meeting, the last class, but I had a question about last class before we start this one because we're still waiting for people,
Yep.
if you don't mind.
Sure.
So we went over you went over intro to programming, and basically most of the premise you were saying is like you want to be a problem solver,
Yep.
or if you're already employed. So with today's job market, you say you want to try to solve a problem for a company, but you first have to try to find out if the company has a problem, which most companies do because they're not making a ton of money. But how do you, as a technologist, approach trying to find a problem for a company and then go about trying to solve that problem to try to, get employment, if you can understand the question?
Yeah, well, the first thing is, if all you're trying to do is get employment, the main thing is that you need to solve problems. It doesn't necessarily need to be their problems. You need to show that you can go out, you can find a problem, you can come up with a solution, and you can implement the solution. So that's why putting stuff on the GitHub is important, where just going around, again, building your own robots and such, basically what the business owner wants to know, is that you can find a problem, you can narrow down on the problem, you can figure out a solution, and you can implement it. Because basically that is what your job actually is. Your job isn't to be a Node developer or Python developer. Your job is to solve problems. And so the skill set that they want to see is that you're going out there and solving problems. So that's where, again, whatever God you believe in, you go to temple, temple, church, right? You go and you ask, hey, is there some kind of web app that might make life useful for you folks? And you find out, we're trying to do food distributions on Sundays and it's a disaster because we don't know where to send the food. We're just using paper to do it. And so you say, okay, so you have this organization that has an issue with managing food delivery. So you use Bottle and whatever to come up with a little web app so that it makes it easier for them to manage food delivery. And that shows you went to somebody, you understood what their issue was, you came up with a solution for it, and you implemented the solution, which is basically what you're going to be doing. Past that, it then gets into industry expertise. So, again, talking about food delivery is something most people understand. Once you get in the world of technology, right, technology businesses have their own problems. Replication strategies with businesses, basically, or with servers. How do you copy data to multiple different servers so that they all have their own store of data and it maintains, being synchronized, right? That's something that a particular business might need help with. And so that's where industry expertise is important, because if you're used to working within a certain, what's called a vertical, so construction, hospitality, whatever, data, if you're used to working within a certain vertical, you'll understand more specifically what kind of problems that they run into. And so obviously the more specific problem that you can solve that relates to that industry, the better it's going to be for you. But the main thing is you just need to go out there and you need to find, again, problems to solve. Build little things for your company, build things for yourself, build things for your team or whatever else, and do that kind of stuff and put that to GitHub, because that's showing the real skills of what we're doing in the tech world. Oops. Does that make sense? Are you unmuted? You muted yourself. Does that make sense?
Yes, it does. It does make sense. And it's the thing. The reason I asked that is because it's really hard to try to get your foot in the door. And so, if you send a resume, or you send an application, or even if you just get a phone call, you're going to get thousands of other people. And I guess it's the skill sets. What they're trying to figure out, like what things could be used to kind of stand out. Would it be the projects or the amount of skill sets that you can show? So say, for instance, there's tons of React developers, there's tons of Python developers, but it's the particular projects that you work that might attract a boss in a sense. Is that what you should probably try to work on? The projects you work on, is that, as well as the skill sets that might be like the thing that stands out?
Well, the thing is, okay, so you need to go and you need to build stuff. The next thing you need to go is you need to do what you need to network with people. So again, it's kind of sad. I just talked with somebody, and they just went through this full multi-year program, and they're like, "How do I get a job?" And I'm like, "Okay, well, you're at the end of the program. What connections have you made? What internships have you done? What meetings have you been to? Who's in your Rolodex?" And this poor person, man, they spent 2 years doing this. They have no fucking person in their Rolodex. So basically, they're walking out with this degree, many ways starting at square one because they've got to go schmooze. So one of the things you have to think about is everybody right now complains about, Eli, I send out 1,000 resumes and nobody gets back to me. Like, what people don't seem to be paying attention to is there's the other side of you sending out 1,000 resumes. So if an employer is getting 1,000 resumes, I can guarantee you 90% of those resumes are going into the garbage can before they take much of a look at them. There's just 1,000 resumes is just too freaking many, right? And so that's why you need to go to meetups, you need to go to tech events, you need to do anything where you can be around other tech people to create relationships with those people so that they know you exist. And again, most of the people that I know when they get jobs, you go, you start talking with somebody, they're like, crap, what is it you do? We could kind of use somebody like you. And then they ask you for the resume. Really what you want in life is you want to be asked for the resume and then you submit it. Then you have a chance in hell of actually getting the job. I really want you to think about this. Like everybody out there complaining, I send 1,000 resumes. Just imagine the poor jackass on the other side getting those thousands of resumes and then ask yourself, how in the world do you think you're going to get a job? And then the other thing too is, again, when we start talking about this niche, is you need to start thinking about, again, what kind of company do you want to work for? What the frickin' hell do you want to be doing in 5 years? Again, I've been doing these meetings again with people. We've had a number of them. Every Monday I do the meetings. And with so many of these people, again, it's like, I want a job or whatever else. And again, the first question I'm going to ask is in 10 years, where do you see yourself? More or less, horseshoes, hand grenades, whatever. In 10 years, what do you want your life to look like? And they're like, I want a middle-class job. What the fuck? That doesn't mean anything. Does not mean anything. Right? Do you like data? Do you like building robots? Do you want to do sales and interact with people? Do you want to do training like I do? Like, what does it look like? What job does it look like? What does your future look like? And then you go out there and when you meet with people and you talk with people, you start narrowing down where you want your future to be. And then you start talking to those particular people about what their particular problems are. It's like, oh, wow, this is a company I would really love to work for. Okay, what kind of technology are you interested in? Where is the 5-year plan for your company? Okay, you guys use React? I'm going to learn React. Oh, you guys use Flutter? I'm going to learn Flutter, right? And that's how you go out and you narrow down to actually get the kind of job you want. Because this whole thing, let me just tell you, for everybody watching, if you do this whole horse crap, and it is horse crap, if you're like, I want a job, nobody cares. They want people that's actually going to want to work for the company. And so that's where it's like you've got to understand what you want out of life, and then you have to understand where the companies and the vertical, how that's going to get you to where you want to go. And again, you can't just say, I want to be $1 billion. Don't get me wrong here. You don't have to be moral and ethical on this. You can't just say, I want to be a rich bitch. It's like, oh, okay, fair enough. Well, this company over here might not be ethical, but they're making a lot of money. So we need unethical people that want to make a lot of money. Right, that's how you go out there. And again, like I say, you talk with people and you schmooze and you figure out what people need.
Thank you. That says it all.
That says it all. There you go. Yeah. The reality of the tech world, admit. But again, like that's the big thing. Again, I've been doing these, so we've done 2 days. So I've talked with 8, 9 people at this point. We're filled up on Monday again. And yeah, like talking with people, it's very interesting when you ask. It's not just young people, even middle-aged people. And it's just like, what do you want your life to look like in 5 or 10 years? Like when you say, if my life goes meh to plan, right? Where is that going to get you to? And again, like if all you can say is house, right, that's not going to work out. It's like, you know what? I've found in my career, I really like being a team leader and I like driving new projects forward, right? I don't get a lot of sleep at night. I'm kind of like Elon Musk. I always want to be working. So, in 10 years, I can really see myself as a startup company troubleshooting. And I really like infrastructure too. So like startup company, troubleshooting infrastructure. It's like, oh, okay, ooh, that's what we can do something with. It's like, honestly, I like the technology stuff, but I really like schmoozing. Like, I do like the technology, but I hate sitting at a computer for 8 hours a day. I do enjoy, talking to people. And so what I found is where I'm really good is being in the middle between the technology professionals and the end user. So I want to find a job like that, maybe something like in sales or in analysis or something. And that's something that is slottable. Whereas you're just like, job. Great. All right. Have fun. Okay. Anyways. There we go. 2:12. I've been blathering along. So let us get to the class. So just so you know, SiliconDojo.com is now our central point for everything Silicon Dojo. So when we have new Zoom classes like this, these are listed here, and you can actually RSVP on the site. Whenever we do these classes, I'm recording this in 4K to the side. You can come here and watch old classes here. They're also on the YouTube channel. We now have this, our self-study program. Python Introduction just got released last night, 2025, 48 modules that I wrote and did 48 videos for. Takes you through basically a whole bunch of stuff. Oops, where is the, and of course I've lost it. There we go. So you can come here and basically, as you can see, you got like the overview, you got the prerequisites, you have the introduction, you have try except statements, again, VENV, you get a nice little video, you get a whole bunch of description, you get the code examples and all that kind of stuff. So that is there for you to use. All of this, of course, is free to the end user. We do get paid. We do get paid through crowdfunding. So there is that nice little link up here that will take you to DonorBox. So if you'd like to throw in a couple of dollars a month, that would be ever so lovely. But anyways, so we have this. We're going to have more of these. So Bottle, the web app framework that we've been using, I'm probably going to do that next. And then we're going to start having a lot more of these just because it's a lot easier for people to follow along with this kind of stuff. You can do the classes whenever you want. And then as I talked about before, we are doing the office hours. So Mondays between 1 to 5, I give you 30 minutes if you want to get on a Zoom for 30 minutes and talk about your career or business or whatever else. Again, you can just sign up here and away you go. Let's see here. Is there anything else? I do not believe so. But let me clean up some of this so we can get to the class today. For the class today, we are doing a little bit of more of a spitballing than I normally like to do, just because I've been working so hard on that Python series. That Python series just kept going and going and going. I thought the Python series was going to take me about 2 weeks to do. Ended up taking me about a month to do, so I haven't had a lot of time to do other things. So we are going to learn about VirtualBox today. As I kind of walk you through it. We're going to take a stroll through VirtualBox. I'm going to show you different things, so it might not be the normal class that we normally do. Anyways, if you do have a question anywhere through it, do make sure to raise your hand in Zoom so I know, and I will try to answer that question as we go. So anyways, let's talk about VirtualBox. So what we're going to be talking about today, the basic concept with VirtualBox is something called virtualization. How do you get better at writing on the board? Virtualization. Basically, when we're talking about virtualization with computers, again, when we talk about virtual stuff, there's a lot of virtual stuff out there. You have Oh, virtual environments in Python. You have virtual hosts in Apache, all kinds of virtual stuff. We're talking about virtualization, though. Generally, what we're talking about is essentially turning an entire operating system into a file. So wouldn't it be cool if we could just package up an entire operating system with all the software installed and all the configurations and all the updates and all the security policies and everything, basically make it a file and then be able to move it around and do with it as we see fit. That is what we're talking about when we're talking about virtualization. We're doing virtualization. You use something called a hypervisor. Hypervisor. And so what the hypervisor does is basically it's a piece of software that allow you to run these virtual machines. So these things are called virtual machines, and each one of them is an instance of a virtual machine. Instance of a virtual machine, instance of a virtual machine, instance of a virtual machine. So hypervisors allow you to run these instances on your computer. There are type 1 hypervisors, and there are type 2 hypervisors. A participant asked to start the AI companion. Fine. Why? Why do we need an AI companion? Have I told you how much I love AI? Anyways, I found in the past, if I don't allow you guys to do the AI companion, you just keep hammering the damn button until I say yes. So I will say yes, but I hate the AI companion. Anyways, we have type 1 hypervisors and we have type 2 hypervisors. Type 1 hypervisors are for the enterprise environment, the real business environment. Basically what happens is you essentially more or less have a rack of servers. On those servers, as the core operating system, as the main operating system, you have a type 1 hypervisor. So if you're in the VM world, at least it used to be called ESXi. I do believe it's still called ESXi. Maybe it's something else now. But anyways, basically you have this operating system that is a type 1 hypervisor, and the only thing that operating system does is it allows you to run instances of virtual machines on that particular box, right? You can't use ESXi to write a term paper or to do QuickBooks or anything else. All it does is run instances of machines. So this is the host machine. You'll hear me say this. There's host. So the host machine is the operating system that is running that allows all the instances to run on top. Then what happens is you've got a whole rack of these things, right? So you literally may have 40, right? So if you've got a 42U rack, you may have 42 1U Xeon servers that all have ESXi. In order to manage a type 1 hypervisor, you need some kind of management software. So again, in the VM world, at least it used to be vSphere. And you have to be careful about this with type 1 hypervisors. This is how they screw you. ESXi is free and open source. vSphere costs you $1,000 a license. That's the real world. A lot of people are like, Eli, we're going to use ESXi because it's free and open source. It's like, great, so how are you going to manage it? What? That costs a crap ton of money. Anyway, so you have this thing called vSphere. So basically vSphere is software that you install on a computer. It then connects to all of your type 1 hypervisors, and you can plug in a whole bunch of cool configurations to do things like high availability. So if one server fails, all of the virtual machines fail over to a different server, and you have load balancing, and you can all do kinds of fun things like that. So that's basically what we're talking about with type 1 hypervisor. ESXi on the bare metal, on the box, with some kind of management server. Now that's great, that's wonderful, but it is a lot of hardware and a lot of architecture and a lot of stuff to figure out. So, wouldn't it be easier, especially for coders, if we could use what is called a type 2 hypervisor, where basically you have your computer and you can open up a new operating system in a window. Right? So if this machine is Mac OS, you can put, I don't know, is that a penguin? You can put penguin in a box and have it running on your machine. You do not need any additional Management software, you don't need to worry about the type 1 hypervisor. Basically, the management software and the hypervisor and all of that is one thing, and that's what you get here. So we take a look at this. Come on. You can see that this is an instance of Ubuntu 24 point whatever else, and I can literally minimize this instance, and you can see that I am running this on a Mac OS. So that way I can basically have multiple instances of operating systems running on this one machine. So like with this, so this is Ubuntu desktop, obviously, and I can literally double click server, and it should be starting up. Dun, dun, dun. And we actually have the server operating system is now coming up here. You can see that. And once it comes up, we have the full-fledged server operating system that we can play with. So again, server, I don't know if you can really see that, the server login. I can log in, user, password 123456, super secret password. And as you can see, we are now in Ubuntu. It gives us system load, the whole 9 yards. And I can go through and navigate the file structure and all that kind of stuff. So basically, with this, what we're able to do is we are able to run these operating systems essentially within Windows on our computer. And the nice part about this too is if we go over to this one, right? So if we go over to this one, so this is Ubuntu, right? So this is Ubuntu. We've seen this kind of thing before. And on Ubuntu, I've actually installed Apache 2, right? So I can go and I can go to terminal. And I can go IP address, and then I can scan, and basically we see we have an IP address of 192.168.1.53. So this is running within VirtualBox. It is pulled an address of 192.168.1.53. I can come to my computer, my normal computer, right? I can go here to 192.168.1.53, and voila! I get the little default Ubuntu splash screen. And so why this can be very useful for you, again, once you start building web applications, whatever language you're going to be building web applications in, is you can build all of that and deploy that to your virtual machine and then be able to access it from the host machine to verify that your web app is doing whatever the hell it's supposed to do. So again, with this Linux machine, it is a full-fledged Linux machine. The operating system is the normal operating system. The permissions is the normal permissions. The file structure is the normal file structure. You are installing just the normal operating system into this instance, and then that gives you the ability to have a bit of this playground. Okay, so if you're taking a look at VirtualBox, the first thing to take a look at is you're going to have to download it and install it. So you go to virtualbox.org download. So go in here. Gives you powerful open source virtualization for personal and enterprise use. Now I will warn you that this got bought by Oracle. There was a disaster in the tech world about 15 years ago, right? So Sun Microsystems, they had been a big player in the tech world. They were going to take over the world until they didn't, right? There was Solaris and their Spark, whatever their systems were. They used to sell Unix systems. Anyways, they're going to take over the world. Their business model didn't work out how they thought their business model was going to work out. And so they decided that they're going to be the home of all of these open source projects. So they went out and they bought a lot of open source projects. They bought MySQL, they bought OpenOffice, they bought VirtualBox, they bought a lot of this stuff. The problem is if you don't have a good business plan, you're still going to go belly up. So they were still failing. And then the true evil company in the world, in the tech world, Oracle came in and bought Sun Microsystems. And so now all of a sudden, truly the worst, most evil tech company bought the company that had purchased all of these open source projects. Oh, fun ensued. Fun ensued. So anyways, if you're going to be using VirtualBox, do realize it's basically owned by Oracle. So, you know, be careful. Be careful. The real evil, nobody talks about the real evil tech companies because they're too scary. Anyways, if you want to use VirtualBox, you come here and you go to download, and then you see you have multiple options here. Windows host, Mac Intel host, Mac Apple, Linux distributions, Solaris apparently still exists, so on and so forth. So you download the one and you install it for what you need. The one warning that I will give you for the Apple Silicon. Apple Silicon runs on ARM processors. So this machine is an Intel, it's a 2019 Intel machine. This machine that's actually running the Zoom call is a M2, right? So that's an ARM. The important thing to understand is that ARM systems are able to run VirtualBox and they are able to run instances of operating systems. But they can run ARM instances of operating systems. So with a lot of the operating systems now, especially with Linux, there are ARM versions. If you have an M series Mac and you're going to use VirtualBox, you have to install the ARM version of Linux for it to work properly, and that can be its own funness if you want to get into it. So if you have an Intel machine, everything should be fine. Just download and install whatever operating system you want. But if you do have an ARM-based system, an ARM-based OS has to get installed in the virtual machine. One of the weird parts about this is open source, theoretically. GPL version 3, you can go read it, personal and commercial use. And again, in the tech world, we've always got stuff in the tech world. And I see you, Todd, I'll get to you in a second. Then we have this extension pack. And so, and this has been around for like 15 years. This has always been weird. So the extension pack adds capabilities to VirtualBox. Adds some USB support, supposed to add some graphic support, add some things. It's not as important as it used to be. 10 years ago, you needed to install the extension pack for it to work worth a damn. Nowadays, not necessarily so much, so you have to decide whether or not you will install the extension pack. The problem here is this is not open source licensed. This isn't. So if you find in the commercial world that you need to use this extension pack, you've got to go through the disaster of their licensing scheme to figure out how the hell you can actually buy this particular license. So that is going to be one of the warnings I will give you with this. And again, it's one of those pitfalls you get in the tech world. And again, as a decision maker in the tech world, one of the important things you need to do is be able to understand the different licensing for the different products. And Todd, what's up, Todd? Todd. Todd. Okay, Todd. 5, 4, 3, 2. Okay, Todd. When you figure out how to unmute yourself, well, I unmuted you. When you figure out how your microphone works, put your hand back up. More than happy to answer a question, but I need to know what it is. Oh, Todd, audio problem. Sorry. Oops. Okay. Yeah, no worries. Just raise your hand when you figure it out. So anyways, okay. So we got VirtualBox and we got an extension pack. So what you're going to do is you're going to download this and you're going to install it, and you should be able to figure out how to do that. Just double click and run it. The next thing that you're going to need is you're actually going to need an operating system to be able to install. One of the nice things when you're running VirtualBox is all you need is the ISO file. So you do not need to turn an operating system into a bootable thumb drive and all that kind of stuff. All you need is the ISO file. So you can come here to Ubuntu or whatever Linux distro you want, and basically you look for whatever it is you're looking for, desktop, server, whatever else. You click on the desktop. You say download desktop, and then that will download the ISO file. If we go and, I don't know if you can really see it, but if we go to downloads, we can see, Yeah, for whatever. So basically, Ubuntu Live Server. So this is the server edition. That's the ISO. And then with the Ubuntu Desktop edition, the ISO. You will notice the desktop edition is 6.2 gigs, and the server edition is 2.7. So that may or may not matter for you. The big difference there, if you don't know, is that the server only gives you command line. Basically, you get a blinking cursor. If you don't know what to do with a blinking cursor, you're screwed. If you use the desktop, you get a nice graphical user interface desktop, which is probably the best way for you to go if you're going to be installing an operating system. Then basically what happens is you go and in order to install an operating system, so this is the path. So when you open up VirtualBox, you're going to see something that looks like this, only you will not have that there. Oops, Doc Filet. Jack, what's up?
Hi, I'm almost home, so I can switch over. But I just want to make sure I understand what a VirtualBox in essence is. It's kind of like a sandbox to try to work on your programs, but in a different operating system. So I have a Mac, yep, but I want to be able to deploy on PCs. So I would deploy a PC on a PC operating system on my Mac. I'm still in an Apple iOS server, but it's still Apple iOS server, but I can put a virtual instance of a PC operating system on that server. Am I correct?
Yeah, so just like this is an instance of Ubuntu, yes, you could install an instance of Windows here. Yep.
Okay. And one second question. When we do instances on there and we run the operating system, does it, so say for instance we're writing one big program, would that instance, when we transfer that and we do it in PC, there's no automatic way that, like, okay, if we open an instance of Ubuntu, then it would transfer all that programming and information to Ubuntu. Do we have to do that all over again for another instance in another operating system?
Yeah, this is a full-fledged server. So basically, this is a server or a computer that just doesn't simply have the hardware under it. So yeah, so if you're going to create, let's say this is Ubuntu, and you're going to build a Windows server, you have to figure out how to get your data from this to that thing. It's just a normal migration process. Yep.
Okay, but you don't have to write everything all over again.
Well, you copy paste. You have to move it as. I mean, if it's a file here, it's a file. So if you can copy it out of here and paste it over there, then no, you don't have to rewrite it again. No.
But even though the file is in a different operating system,
you do understand.
Can I repeat the question I'm asking? Because there's iOS, there's Ubuntu, and then there's PC, and even though the file the structure is still the same, but it's still operating under a different system. But it's just easy just to copy paste, it'll work just as fine. I'm just making sure I don't mean to aggravate it.
A PDF is a PDF is a PDF is a PDF. .txt is .txt, .txt, .txt. If you take a PDF and you open it up on Ubuntu or Mac or Windows, it's still the same file. So you can take the file from there to there. Yeah, files are just files, right? So if you go to a website and you download a text file, whether you download it on Mac or whether you download it on Windows, it's still just a text file. Yep.
Okay, thank you.
Okay. Where was I going? Okay, so we'll go back here to VirtualBox for a nice little stroll. Can I make that bigger? Anyways, hopefully you guys can see this. Put it closer to there. Okay, so basically you will not see here. Well, you will not see this. Up here you'll see new, add, settings, show, whatever. So what you're going to do is there's this little star thing right here, and that is what you would click on for the new. When you get the new, it's going to ask you what name do you want for this thing. So I can just do class. So basically this is going to be the name of the virtual machine. This allows you to find the file itself if you need it. Folder, where is the virtual machine going to be stored? So users, Eli, VirtualBox, VMs. So I do think it's interesting to go there. So we can take a look at this. Oh, Eli. Date modify. VirtualBox. You actually have a folder called VirtualBox VMs. and we have server, test, and test2. So if I open up server, you can see that I actually have a VDI file. So I don't know if you can see this. It's called server.vdi. So this is the file for the virtual machine. And if you're going to go over here, you can see it takes 4.14 gigs. So basically, this is where the file is stored. Then you go to the ISO. So you downloaded the ISO. And so basically here, it asks for the ISO image location. You click on this, and then basically you can go to other, or if it's already there, you can say what you want. So let's say I want the live server. I can click on that. It should auto-detect what it is. Type Linux, subtype Ubuntu, version Ubuntu. But if you want to change this for whatever reason, you can do that. We have unintended install. So this can be useful whether or not you actually want to do it. So you can actually plug in the information, so the username that you want for the system, the password that you want for the system, the host name that you want, even a domain name if you want. You can do all of that here. Or you can actually, you can simply say skip unintended installation, and then you could type all that stuff out if you want. We can go and take a look at the hardware here. So we have base memory, and then we have processors. So this is going to be a big issue here for you to be looking at. So basically, with the memory, this is how much RAM are you going to be giving to the virtual machine. All right? And this is where everything can go to hell. This is where everything can go to hell. You need to understand basic math. You don't need to understand a lot of math, but you do need to understand basic math, right? So basically, you have your host machine. You have your host machine, with it, which is my my Mac here, and we've got 32 gigs, right? So I've got 32 gigs of RAM, and that is on the host machine. The thing is, whenever we spin up an instance, right, basically, VirtualBox is going to reserve the amount of RAM that we signify here. So if we give our little server here, if we give our server here, 32 gigs of RAM, basically, as soon as we try to start this virtual machine up, it's going to take all the RAM, and everything's going to go really bad. And so basically, one of the things you have to think about here is how much RAM do you think your virtual machine actually needs? So this is in megs, so this is like 2 gigs. Does a command line version of Ubuntu need 2 gigs of RAM? Does it need 1 gig of RAM, 2 gigs of RAM, 5 gigs of RAM, 20 gigs of RAM? That's one of the things that you have to figure out. This can be changed. This can be modified later. So if you get it wrong, it's okay. So you can basically give it 1 gig of RAM, see how well it works, and then start putting it up and down until you find the sweet spot. The issue is, though, is every one of these instances is going to have RAM allocated to it. All right, so if one instance you allocate 10 gigs of RAM to, all right, that's fine. You still got 22 gigs left. Well, then this you give 5 gigs to, and maybe this you give 8 gigs to, and then crap, this is doing some AI stuff, so we need to give 10 gigs to that. Maybe we do 2 gigs to this, and maybe we try to do 7 gigs to that, and then all of a sudden, you have much more than 32 gigs. So you got to be careful. The thing is, with the RAM, just so you don't get confused, this RAM is only used once you spin up the instance. So if you create this instance and then you turn it off, it's not on. So it's just a file, it's not actually actively running, then you're not using that RAM allocation. Where the RAM allocation gets used is when you actually spin it up and you are running that particular instance. And that's one of the reasons it can get a little weird too, is you could have multiple like 10 gig instances. Most of the time you only run 1 at a time, and for some reason you try to run 3 at a time because you're working on a project, and all of a sudden something goes to hell. Then you can go here to the processors. You can see how well this processor works. So again, this is an Intel MacBook, theoretically. It's got 12 processors in it. So for this particular machine, you can go through and you can give it virtual CPUs. This is kind of one of those things, play with it and see what happens. Again, do be careful with over allocation. We can then come down here to hard disk. This is where we say basically how big we want this file to be. So the hard disk file location, so this is VirtualBox class, class.vdi. And so basically we say here that we want it to be 25 gigs. So the system has up to 2 terabytes of storage. We are going to give this 25 gigs of storage. Again, be careful with this. If you do not give it enough storage and you have log files or whatever else, you might use up the entire drive. That can be its own problems. There's different types of virtual drive disks. Basically, think about this as like a file format. The difference between JPEG and JPEG and PNG and that type of deal. I would say keep it to VDI unless you know there's a reason you need to put it somewhere else. You can use an existing virtual hard disk. So if you have an existing virtual hard disk, you can simply connect to it, and then you can use that for what you're spinning up. Or you could say do not add a disk. Not quite sure why you would do that. Basically, you would then do finish, and then we have our class powered off. When you go to install, we're just going to start the install process. I don't want to go all the way through this install process because it does take a couple of minutes. When you go to install, you then double click on class that we created, and we can see it's starting the virtual machine. I can then do view over here, screen size, and try to increase the size of this thing. View. There we go. So we have this instance. It asks us, do we want to try or install Ubuntu server? We just hit enter. And now we're going to go through the stock standard installation procedures for installing server. Again, you're going to see all this stuff go by. And basically, as far as this installation is concerned, it thinks it's being installed onto real hardware. And so there isn't going to be any real difference when you run this. Should be pretty normal. We'll just kill this. Oops. We'll just kill this so we don't run into any issues. Basically, you can hit the X up there. You can say save the machine state. So this is kind of cool. One of the things is you can close. You can close the virtual machine, but you can close it basically at the state that it's in. So basically, you just freeze it right there. That can be useful. You can send the shutdown signal, where basically you tell it to turn off, or you can just power off the machine. As I like to do, you just basically rip the cord out of the wall, and you power it off, and it goes away. Okay. Now, if we go and we take a look at, let me power this one off. Stop. Power off. So we take a look at the machine. So this is the graphical user interface. So this is Ubuntu desktop version. We can go to settings, and this is where we can change settings once we've created the machine. So we have the name here, type, that type of thing. Base memory, so we can change the base memory here if we want to. We can actually give it boot order. Again, it kind of thinks that it's a real computer. It wants to be a real computer. It's not, but it thinks it is, right? So you can actually give it a boot order. Let's see here. You can change pointing device. You can change a whole bunch of stuff here. Screen size. You can do monitor count. So in the modern virtualization software, you can actually have multiple monitors. You get to play around with that. Scale factor might be useful. So this is basically how big initially do you want the screen to be to scale in size so you can actually view it on your machine. This can be very important, especially with Macs, right? So Macs essentially have 4K screens. So especially when you deal with Linux, like Linux initially installs with like a 480 by 640 screen. So basically, if you don't use the scale factor and you go to install Ubuntu, you're going to get a screen that's going to be about that big, where if you've got good eyesight, you could type in all the commands, but sometimes you run into issues, so you can change your scale factor there. Graphics controller shouldn't be a problem, but if it is, you can take a look at that. We have storage here. So this shows our hard drive. So again, virtual size of 25 gigs, currently using 6.92 of it. Here is interesting. You can actually add an optical drive. So basically what this is generally going to be for is those ISO files. So if you get an ISO file of something else, so let's say you have Windows, especially. So you have Windows, you need to install a piece of software into your Windows virtual machine. If you have an ISO of the disk of the software that you want to install, you can actually go here, and you can choose a disk file. So basically like an ISO. See these ISOs here? So if I click on that, that will actually now essentially put that ISO file into the optical drive so that when I boot, or I can basically get access to it, that type of thing. So that's there. You can delete the optical drive. We can come down audio, so you can get audio out of it. And then we get network. So this is going to be one of the important ones for you folks if you're trying to do servers and actually be able to interact with the server. So enable network adapter. So make sure your damn network adapter is enabled or internet's not going to work for you. Then you have attached to, right? You have NAT. You'll notice here, if you can see it, I have it set to bridged adapter. So if you have it to NAT, so network address translation, basically what happens with network address translation is that your host machine acts as a router between the instances and the rest of the internet, right? So you have your host machine and you have your instances. And if you have it set to NAT, what happens is your host machine does the network address translation. And so basically, you get DHCP. So it runs its own little DHCP server. So all the instances on your host get their IP address. So like 10.1.25.6, right? And then the computer and the rest of the network is down to, let's say, 192.168.1.x network, right? 192.68. Anyways, so basically the issue that you can run into here is that the instance can get access to the internet. So it can go to Google, it can download files from repositories and all that kind of stuff, fine. Because it's got a valid IP address, it's going through NAT, it gets routed to the internet. The issue though is this IP address range is different than this IP address range. So the host machine actually is not able to communicate with the instances that are running on it. So this is a way from a security standpoint that basically you can isolate your instances of operating systems running on a host so they can get out to the internet, but they can't really communicate with the underlying host operating system relatively easily. The issue is if you want to run a server, like I showed you, you want to build a web server, you want to have your host machine be able to communicate with that web server, then that's not going to work. That's why you use bridged adapter. And basically what bridged adapter does is it simply makes a little bridge, right? So, you got your host machine here, you got your instance here, you got your little network card or wireless card or whatever here, and basically it just creates a bridge. It just creates a bridge through here. So your host gets an IP address of 192.168.1.10, let's say from your DHCP server. And then this is also now on your LAN. So it pulls an address, so it's now 192.168.1.22, let's say. And now those are on the same network. So the instance can communicate with the host over the network, and the host can communicate with the instance over the network. And that is where bridged comes in. Then you have a whole bunch of different options here. You can do internal network, so if you want to create a lot of instances and have them only be able to talk to each other, you can do an internal network, and there's all this other stuff that you can play around with. Let's see here. Beyond that, cable connected. Make sure you check off the checkbox that cable is connected. That's a way to disconnect the cable. Anyways, let's see, serial ports you probably aren't going to need. USB controllers, that might be an issue that comes up. And you can have shared folders. So you can actually have shared folders on the machine. So if you want to be able to swap files back and forth, you can actually signify which folders should be shared so that the host machine can see that folder and the instance can see that folder, and you can kind of copy and paste back in a limited security way. So that's what you're going to have going on there. Let's see here. If we exit out of this, discard the changes, we can then bring up the actual instance itself. So this will be Ubuntu graphical user interface. Basically, you can see this. This is how it works. We're pulling it up. Get a nice little splash screen. And there we go. So again, now we have Ubuntu 24 point whatever 10 that's actually running here, and you can go and you can configure all the settings and all that kind of stuff. One of the things you do have to be careful about, especially with graphical user interfaces, is the display. You can dork this up pretty quickly. If like we go to displays and let's say we do 200% and we do apply, I'm not going to keep it. It's hard to see. But anyways, you can actually make it so that the screen ends up becoming bigger than the window. So that can be a bit of a problem. That's something you have to be careful about. You can reverse settings. One of the biggest issues you're going to deal with, honestly, with dealing with virtual machines is just having the display work properly so that it looks okay. You can do the resolution here. So this is set to 1920 by 1080. So I can change this to... I do this to bigger, or I can do this to smaller. See how well that works. Oops. You do apply. You keep those changes. So that doesn't look too bad. Right? So that gives you. So again, depending on what you're trying to accomplish there. And then everything else in here again is just Linux, right? Again, I can just go out since it's got that bridged adapter. I can simply go out to the internet. Yeah. And we can go to the world famous CNN.com. Again, it's just basically a normal computer at this point. Let's see here, what else to show you. You go up here. So on the toolbar up here, you got some different options. You got the preferences, got machine settings, things I showed you before. One of the things too is the view. So we can adjust the window size, we can do scale mode, we can do full screen mode. So again, depending on the screen size, you want to do full screen mode. It might not take up the full screen. Let's see here. You can do virtual screen. You can scale it. So if I want to scale it to 300%, that makes it a little easier to see. Again, that's the kind of thing you got to play around with. We have devices and webcams if we want to try to access those. So let's see here. FaceTime, camera. Oops. Yeah, this is one of the problems. It's like when you change the size, you might not be able to get to everything you need to. There we go. So we got the settings down here. And where's cheese at? Does it have cheese? No, it doesn't have cheese. Anyways, never mind. So anyways, that allows you to connect to things like, again, optical drives here, audio if you need to try to do it, USB settings if you want to do it, webcams, shared folders, so on and so forth. And so that's basically the idea of what we're talking about with VirtualBox, is this just simply allows you to create this virtual machine on your system, be able to deploy your apps to it, be able to interact with it, either from your host or from a different computer. So again, so this machine right now, right? This machine right now is on the network. So, oh, not that. Let's see if I do. So I go to, what was it? Safari. So I do 192, oh, there we go, .53. So yeah, I don't know if you can see that. So 192.168.1.53. Again, my phone is on the Wi-Fi. So that again, as I'm saying, as far as every other system is concerned, this is a full-fledged server. So again, especially in your own environment, if you're doing testing or whatever, you can spin this up and then you can have other people that are on the same Wi-Fi be able to connect to your server, play around with it, do some user interface testing, that type of deal, to see if everything's working properly. Yeah, I guess that's about it. I guess it is a short class today. It's a short walk through the woods of virtualization. That's really basically all there is to it. Again, you can download it, you can play with it, as long as you don't use the extension pack. You can use it for whatever you want. It is free to use, and it works relatively well. The one warning that I'll give you is if you're using an M series Mac, you can only use ARM operating systems. So do make sure you understand that when you're going to use an M2 series Mac. But otherwise, again, in the modern world, it works pretty well. Are there any questions then? Questions in our very short class. Let's see here. We got Nilton. Nilton says, can Android run VMs? Android is Linux. So depending on what they've ported to Android, you may or may not be able to run VMs. I don't know who's running Android on a desktop environment. Theoretically, you could. I don't know how to do it. I've never played with it before. How the networking side works running several virtual machines in the same server. Does the full OSI model operate between them, i.e. ARP and low-level layers to communicate between each other? Should every VM need having a physical Ethernet interface? No. Yeah, so more or less the OSI model works. Oh, people bringing up the OSI model. That's dangerous. That's dangerous in 2025. Yeah, basically, it's virtualized networking. So it's a virtual networking stack that, I don't know, as far as I am concerned, works the same way as a normal networking stack. So you have your host machine, right? You have your virtual instances in here, right? So there is a software networking layer in VirtualBox. And so basically what's happening is these virtual machines are connecting to that software networking layer that's there, and then based off of their configurations, when they go to use the networking port, so either the hardwired NIC or the Wi-Fi, when they go to use that, this will determine what they're able to use. So again, if they have a bridged connection, then what's going to happen is they're going to get the DHCP address from the outside world, and so they'll be able to communicate with everything through an IP address normally. If they have simple NAT, what will happen is this networking layer will see that, and so it'll say, okay, so you can communicate all the way out to the internet, and you can communicate amongst each other, but again, it's a different IP address scheme. So 10.1.20.2, right? That is a different subnet than 192.168.1.x. So therefore, that subnet does not communicate with that subnet unless you got a router or something in between. So if you have just NAT, this knows that, and so the host and the instances will not be able to communicate over the network. But again, let's say this is 10.1.20.2, and this is 10.1.20.55, and this is 10.1.20.78, right? They're all still on the same subnet, so they'll be able to communicate with each other. And yes, there actually is a MAC address. Do you get that IP address? Oh. If I go to IP, that's not the MAC address, Ethernet, there we go, Ethernet link. So that right there is your virtual MAC address for this virtual NIC. So yes, you do have a MAC address. Again, so MAC address works at layer 2 of the OSI model. There's something called the OSI model. It's 7 layers. It's a representational model of how network communication is supposed to work. Layer 1 is physical layer, the actual network connection. Layer 2 is a switch layer. Layer 3 is TCP/IP, the networking layer, so on and so forth. Anyways, at the Ethernet layer, everything has to have a globally unique ID, and that's called a MAC address. Half of the address is supposed to be an identifier for the vendor. Half the address is supposed to be an identifier for the device itself. So it's kind of like a serial number here. So even though this is all virtual, you still have to represent the normal stuff that you would have within that virtual environment. And so this is what we start talking about with like the virtualized networking stack, is you still have everything like MAC addresses and such in here. So if I did an ARP, if I did ARP-A or whatever, let's see here. If I go back to my host machine, I'll be curious with that. Let's see here. Shell, new tab, Pro. If I do the ARP-A command, this dumps my ARP table. Let's see what it says. There we go. There we go. So as you can see here, 192.168.53, so that's the IP address of our virtual machine. And we have the MAC address right here. So yep, it's normal ARP address resolution protocol and the whole 9 yards. Oh, let's see here. If you have questions, raise your hands. Raise your hands. One Frog 9 in the comment section, or the chat section. I have a question separate from virtualization. Will you be doing any classes on cloud infrastructure? Also, I live in Asheville, and I was curious if there might be local educational networking events focused on cloud infrastructure. Will I focus on cloud infrastructure? I don't know. All infrastructure is cloud infrastructure. I'm just kind of doing a massive brain dump at this point in time. I'm trying to take this data, just trying to put it down into video. So, yes, when? I don't know. We will do Azure. I like Azure. We will do AWS. We will do more things. I'm going to focus on this more basic stuff now just to kind of get through it. So it's now been put onto paper or been put onto video. But we will do stuff going into the future on that. Is there any local events focused on cloud infrastructure? Dude, you're in a city of 90,000 people. We have no tech events focused on anything. We have tech events. Just to get enough people to show up at a tech event, we kind of just got to invite everybody. So anyways, if you are in the Asheville area, the meetup that I would highly recommend you go to is Meet the Geeks. Meet the Geeks. Well, there's the meetup. It's a non-profit, but been around for God knows how long. This is Meet the Geeks. They get together every other month. So the last time we got together was November 20th. So I guess we're going to be getting together this month. So in January, they post it here. They got about 2,000 members. I don't know. They get anywhere between like 40 to 60 some odd people whenever they do their events. And they've got all kinds of different people. So they have a lot of data people. We've got a lot of data people. Again, that's one thing to understand. Like when you're trying to get a job, one of the reasons why you got to go to network is you might be surprised with what opportunities are in your area. So like Asheville, of all places, actually has a lot of data opportunities. And nobody can explain why. I've talked to the data people, and they're like, I don't know. The jobs are just here. Like there's just this weird thing. Like they just have a lot of data here for some reason. Anyway, so when you come to this, you got all kinds of people, everything from sysadmin to ISPs to data, lots of data people for whatever reason, to the remote workers and the whole 9 yards. But so this is the best meetup to go to, and then past that, yeah. Be happy we have any tech events. Literally, this is not a joke, right? So there's something called digital nomads, right? Digital nomads. Let's pull it up. Digital Nomads AI. Asheville. AI hacks. Oh, I don't want to frickin'. Come on. internal server error. God. Oh, you ever have one of those times? Digital nomads. Oh, come on now. This was supposed to be a lot faster. Digital nomads. So anyways, digital nomads. Dun, 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 dun. This is an interesting meetup. If you haven't been there, it's basically for remote workers. Anyways, there was a point. They got like 3,000 members. Go to past. Fuck me. Anyways, they have an AI meetup. They have an AI meetup. I don't know, for normies to play around with AI. Anyways, I actually sponsor the AI meetup. And the reason that I sponsor the AI meetup is after a year of going to it and not seeing any pizza whatsoever, it made me sad. Remember the 1980s when there was the television ad where somebody threw garbage out of their car and then an Indian cried? That's kind of how I felt at this AI event. I was like, how do you have an AI event with 50 people showing up and nobody in Asheville cares enough just to buy these people pizza? It made me sad. So I'm literally buying them pizza. I'm sponsoring them just so they can have pizza at an AI meetup. So that's kind of the level the tech community is at. You get sympathy pizza here. You get sympathy pizza. So yes, come to whatever event is available. Meet the Geeks is good though. Meet the Geeks. Okay. Anybody else? Anybody got a question? Because it is Friday. I would say I can go home, but I'm already home. So I'll just go and drink some coffee or something. I don't drink beer, and I haven't had beer in like 2 months either. Trying to slim down, get all athletic again. So, anywho, any more questions? Questions. Tequila is plant-based. Yeah, it's all alcohol. It's the alcohol and then the calories. Honestly, I just can't do it anymore. Like, you just get to an age. I think that's the thing. Like, I don't know if when you get older you can't do it, or you just decide you don't want to feel bad anymore. Because like when we came here, it's during COVID, like I drank beer, and then after COVID, drank beer, like this is Beer City, USA. And then I swear to you, it was just a couple months ago. I was just like, I just don't want any beer anymore. I just really don't want alcohol anymore. It kind of makes me croupy, kind of gives me a little bit of a headache. Honestly, if I'm drinking, it's usually because I'm bored, so I might as well go do something I actually want to do. So anyways, I'm going to have some coffee. Okay, anything. Some VM tool that runs on Linux is Oracle tool running on Linux. It runs on VirtualBox. Again, if you look at the downloads, they have the Linux distributions here, and they've got Ubuntu for 20 point. Well, I don't know if you can see that. Anyways, so for Linux, you can run it on Red Hat Enterprise, Ubuntu, Debian, Fedora, OpenSUSE, or however you want to say it, all distributions. You can run it in a Linux environment, and you shouldn't have any issues. I haven't run it in Linux for a while just because I haven't cared, but when I have in the past, I don't think there's any weird issues that you would run into. So it should be good for you. Okay then, you guys are a quiet lot. You're a quiet lot today. So there we go. No questions then? Yeah, so as I said, for Silicon Dojo, we do now have the self-study program. So this is the Python series. I'm going to continue with this. So we're going to have a bottle series. We're going to have a SQL series. SQL, for those kids out there. Oh, I found out why it's called SQL. Well, my generation calls it SQL. There's actually a reason for things. Like there's all this stuff that we do, we have no idea why. So why my generation calls SQL SQL, because that gets in a lot of people's nerves, right? The kids, those 18-year-olds, right? Why do old people do things wrong? Anyway, so I call SQL SQL. And I have all my life. Like when I learned the word SQL, it was like in 2000, and everybody called it SQL. Anyways, never thought twice about it until you start doing YouTube videos, and then people give you crap for the stupidest reasons. So I was reading something about kind of like the history of SQL, and apparently what it was originally the original acronym, the original letters for SQL was SQEL. So it used to be called Structured Query English Language. And so then people called that SQL because SQL, I don't know, that makes more sense for calling it SQL, right? Structured Query English Language. Then, time moves on a little bit. The world gets a little bit bigger. They drop the whole English part, shrink it down to SQL, and now kids call it SQL, and the old timers still call it SQL, and we don't even know why we call it SQL anymore. So that is apparently why my generation still calls it SQL, and the young kids all out there call it SQL, because the generation that was even older than me had an additional letter in there. So anyways. But yeah, we're going to have SQL classes, and JavaScript, and all kinds of stuff. And that is what I'm going to be. This is going to be one of my priorities going into the future. So if you're interested in it, that's there. And again, like I say, for office hours, if you want to talk about your career, or again, should you use Mac OS or Windows, or should you deploy to Azure or AWS, or any of that kind of stuff, we do have the office hours every Monday. And with that, I will call it a day. No more questions? Okay. See y'all later.